All right, we'll go ahead and kick things off. So again, thanks for joining. So my name is Joe Mann. I'm a staff multi-cloud architect here at VMware. My main focus at VMware is enabling our customers and partners on all things cloud native with a focus on the VMware Tanzu portfolio. I'll be joined by my peer, Chestin, who is a senior solution engineer focused on the VMware Cloud Provider Partner Program. So he'll be joining, helping out with Q&A and moderation of the session. So hopefully you've joined us for the previous two sessions in the previous weeks where we kind of gave an intro to the VMware Tanzu portfolio and then dug into vSphere 7 with Tanzu, as well as Tanzu Kubernetes Grid and its various iterations. Today, we're going to focus on VMware Tanzu Mission Control, which is our SaaS offering for multi-cluster, multi-cloud Kubernetes fleet management solution. So this will be the last of our three sessions. A big thanks to all of you that have joined, as well as the phoenixNAP team for working with us to put this series on. So as previously mentioned, this session will be focused on VMware Tanzu Mission Control for session 3. The phoenixNAP team has put the recordings for session 1 and session 2 on YouTube for review. So as mentioned in previous sessions, all of these, excuse me, all of these sessions for the hands-on portions are using the VMware Hands-On Lab or HOL platforms. So those are available to any user for free at any time. So you can go in and check out these labs and walk through these scenarios again if you maybe missed it the first go around, or during today's hands-on portion if you want to follow along live with me, or just kind of observe. You can go and take the lab and check it out and do it on your own time anytime you wish. So today we're going to focus on Tanzu Mission Control. More specifically, I'm going to do a quick recap of what we covered in the last session. I'm going to introduce the VMware Tanzu Mission Control. TMC is the acronym we use for short to refer to the product. And then we're going to look at a use case overview for Tanzu Mission Control or TMC to kind of look at, what are the different problems we're solving and helping customers and partners solve with TMC. And then we're going to walk through a couple of scenarios in the live TMC HOL lab. So we're going to look at both provisioning TKG clusters as well as attaching existing Kubernetes clusters to TMC for policy management. We're going to look at some policy management modules. We're going to have a look at conformance testing, and then have a look at, if we have time, have a look at data protection to see what it looks like to do backup and recovery of Kubernetes clusters via Tanzu Mission Control. So that module is not in the public lab yet. We have written it and tested it, so we have that available privately right now. We'll be releasing it for VMworld, so you won't be able to follow along with me just yet, but hopefully I'll be able to showcase that and demo it live on the session to kind of see how it works. So first of all, just as a quick recap for what we covered in the last session, we mainly focused on the Tanzu Kubernetes Grid offering, which is VMware's solution for an enterprise-grade supported Kubernetes build that can be run on any platform, on any cloud, and in any virtualization infrastructure. And so the vision here is that we have TKG management endpoints both built into vSphere with Tanzu and vSphere 7, as well as using TKG multi-cloud to instantiate these management endpoints on various clouds. And so the experience for the end user is very similar no matter what the underlying infrastructure is. So this allows really for scale and ease of use in managing Kubernetes clusters. Something I'll say, and I've said in the past sessions a bunch, is that anyone can read some documentation and build out a Kubernetes cluster from scratch, maybe one time. But when it comes to deploying tens or hundreds of clusters or managing the upgrade process for those clusters, that's when things get out of hand. So having some sort of life cycle management tool, is incredibly important in this space. And so really the lifecycle management solution at the basis of our entire Kubernetes portfolio is cluster APIs. So utilizing Kubernetes style primitives to manage Kubernetes clusters. So declarative lifecycle management of Kubernetes clusters is really the main tenet of the open source cluster API project. And so really how that manifests itself in the Tanzu Kubernetes Grid portfolio is that the platform operator has some sort of desired state configuration that they pass to some sort of Tanzu Kubernetes Grid management endpoint. Now that is either the supervisor cluster in vSphere 7 with Tanzu or a TKG management cluster in TKG multi-cloud. And as we'll see in the lab today, Tanzu Mission Control also utilizes cluster API as the management and lifecycle management engine for provisioning and managing Kubernetes clusters. So the basic workflow is exactly the same. The difference with Tanzu Mission Control is that instead of the platform operator being forced or required to use the CLI to create clusters, TMC provides a web UI that allows for kind of a button click experience of provisioning clusters today on AWS, and then in the very near future on vSphere 7 with Tanzu, vSphere 6.7, as well as Azure on the roadmap. So we're essentially utilizing the cluster API project to provide lifecycle management for TKG, vSphere 7, as well as Tanzu Mission Control. So that's kind of the unified lifecycle management strategy across our entire Kubernetes portfolio. And so this is what we talked about from a TKG multi-cloud workflow installation standpoint. We covered this for vSphere 7 and the TKG service in the first session, but this is essentially what happens for installation and configuration of TKG multi-cloud. So we have some sort of local virtual machine or bare metal server that has the TKG CLI and Kind or Kubernetes and Docker packaged on it, and then the end user uses the TKG CLI to start the process of spinning up the management cluster. And so that involves using Kind to build a bootstrap cluster to provision the underlying virtual machines and infrastructure on on vSphere or AWS or Azure in the future, or VMC today, VMware on AWS. And then once the management cluster is provisioned, that essentially becomes the management endpoint to provision X amount of workload clusters. So what Tanzu Mission Control will do is essentially attach on to these various management endpoints to allow for kind of a web UI experience of provisioning and managing Kubernetes clusters. What we see here in this process is all done via the command line, but we're going to offer a web UI and button clicking experience when we have TKG multi-cloud integrated with Tanzu Mission Control. So that's basically kind of the recap from our last session. So now, before we get into the hands-on lab portion of the session, I wanted to just introduce the VMware Tanzu Mission Control product itself. So when we look at the Tanzu brand, we really have kind of different areas that we're focused on. So we have the build kind of pillar, so allowing developers to kind of build modern software, and this is mainly Tanzu Application Service, Tanzu Build Service. These are products that are coming over from the Pivotal acquisition. And so that is really our strategy for allowing developers to kind of build modern applications on any sort of infrastructure. In the run pillar, that's really where we've been focused on the previous two sessions. So how are we enabling infrastructure teams and customers and partners to consistently build, deploy, and manage Kubernetes infrastructure to support these modern applications? So we need to be able to, or VMware wants to be able to enable our customers and partners to support the build pillar or the modern application, modern software supply chain. So we need to be able to provide infrastructure teams with scalable solutions to build, manage, update, upgrade, scale, automate the creation and management of Kubernetes clusters. So that's where the run kind of pillar comes into play. This is vSphere 7 with Tanzu Kubernetes Grid that we talked about in the previous session. Today, we're really going to focus on the managed portion, and this is where Tanzu Mission Control comes in. Tanzu Mission Control comes in. So really, this is multi-cloud, multi-cluster, multi-app management. So our aim here is to create kind of a window for both operations teams, infrastructure teams, and developer teams to kind of have a 10,000-foot view of their entire fleet of Kubernetes clusters, no matter what cloud they're running on, where or how they've been provisioned, to be able to allow operations teams to kind of layer access and security best practices and policies over kind of groups of clusters. So before we go into the actual product, I want to acknowledge that technologies such as containers and Kubernetes are something that we see customers adopting if they haven't done so already. Because these technologies really provide a lot of benefits both for developers and operators, and these technologies are the driving forces behind the cloud native and digital transformation movement. So we talked about this in the very first session. This developer velocity and application velocity and acceleration is really what is differentiating businesses as they look to kind of get a leg up on competitors. So being able to empower developers to test, build, deploy to production, quicker. So for developers, containers and Kubernetes specifically can help them ship code faster. They'll be able to make changes to the application and push those new features much faster than having to do it on, a monolithic application design. On the other side of that, operators will be able to enjoy a more consistent cloud-like operations because Kubernetes really offers a declarative style of management that really makes things easier from that operational standpoint. Another benefit is that ISVs are increasingly starting to package and deliver their applications in containers. So installation and configuration of these apps is way more simplified. These ISVs ship all their requirements and libraries inside of the container. So they can ensure that the application will run consistently no matter what infrastructure is deployed on, as long as it's on a conformant Kubernetes solution. And then finally, Kubernetes can really provide better resource utilization over VMs. So being able to squeeze the last little bit of blood out of the turnip, so to speak, to get kind of the necessary requirements for getting the most compute out of your hardware or public cloud providers' hardware as possible. So the speed of container and Kubernetes adoption is really skyrocketing in the recent years. And the typical enterprise Kubernetes adoption normally starts small, maybe just one team developing one application and deploying on one cluster. So, we don't really see kind of the problems of scale at this point because our customers are just kind of dipping their toe in, so to speak, and this new type of infrastructure, this new type of application development. But what happens when this goes into production and we have multiple clusters, maybe tens of clusters at the beginning, hundreds of apps? We start to scale these things up. So once the adoption starts, it really can kind of quickly accelerate. And when more and more teams start to adopt containers and Kubernetes to develop and deploy their application, the landscape starts to get really, really crowded. So there could be multiple teams deploying multiple applications onto multiple clusters in various different environments and infrastructure platforms, on-prem, public clouds, or even bare metal. So according to an IDC report, in the next 5 years, they stated enterprises will build 500 million applications using cloud native tools and technologies like containers and Kubernetes. So that's really equals the total number of apps built over the last 40 years altogether. So with so many applications being built in organizations, you can start to see how the landscape can get even busier in such a short period of time. And from a VMware perspective, one reality we're seeing today along the Kubernetes adoption journey of lots of enterprises is a lot of fragmentation. So you have team A, B, C, and D, and they may have their own strategy, their own infrastructure platform. You have a group of developers that have got a hold of a credit card that are going to AWS and just using whatever AWS is offering, or going to Azure and using whatever Azure is offering without any sort of governance. And so it's hard for operations teams to kind of reel that in. And obviously this is valuable for the application teams because they can get what they want on demand with really a very low barrier to entry, but it brings a lot of problems into the operational side. So for example, how do the operation teams gain visibility into these clusters? How do they troubleshoot across these different environments? How do they enforce security posture, compliance requirements, and what about managing cost and consumption across infrastructure? So the operational tools that our users have today really, we don't feel they really meet the needs. A lot of Kubernetes management tasks need to be done manually, and if you're manually managing clusters running in multiple clouds, your world might look something like this, you know, multiple terminal windows, multiple screens, multiple cluster consoles, just to assign access or a role binding to one cluster. And so being able to grant a team or a user access to multiple clusters is a very manual effort without some sort of management solution laying over the top of your Kubernetes infrastructure. So as IT and operations teams are concerned, how do they manage that fragmentation in a way that doesn't impose limits on the developers, so it doesn't create kind of a new roadblock or stumbling block for developers, but also improves the operational efficiency and reduces kind of risks and errors that are popular. So that's where we feel Tanzu Mission Control comes in to help solve some of those problems. So to help our operations teams manage this growing fragmentation as more teams begin to adopt containers and Kubernetes, but also not creating kind of more technical debt for developers to interact with the infrastructure. So we want, again, this is kind of a common theme through the entire portfolio. We want to give the operations teams control and insight into what's happening in the developers world, but we don't want to make things harder for the developers. So VMware Tanzu Mission Control is a centralized management platform for operating and securing Kubernetes infrastructure and modern applications across multiple teams and multiple clouds. So it provides operators with a single control point to give developers the independence that they need to drive business forward while enabling consistent management and operations across environments for increased security and governance. So with TMC, the developers do have the ability to self-service and have self-service access to Kubernetes for running and deploying their applications. But at the same time, the operations teams can set up scale guardrails, security guardrails, access guardrails to ensure they have kind of a consistent set of policies across their entire fleet of Kubernetes clusters. So in addition to that, TMC allows those operation teams to really strengthen the security over the application. So it lets you easily manage security and compliance over the entire Kubernetes footprint. So let's just talk about some of the use cases from a high level here before we start to dig down. The first thing I want to talk about is Tanzu Mission Control has two kind of what I'll call categories of cluster management. On the left side, we have provisioned clusters. On the right side, we have attached clusters. So I'll start with attached first. So as you may infer, attached clusters are clusters that weren't provisioned via Tanzu Mission Control, but have been attached after the fact to be able to be under the control of TMC. And so the value there is that TMC can come into an existing brownfield Kubernetes environment and instantly be of value. You don't have to redeploy your entire stack with TMC to be able to utilize the features and functionality. The only feature that you don't really get for attached clusters is cluster lifecycle management, because TMC doesn't really have visibility and access to whatever the lifecycle management strategy is for existing clusters. So you won't be able to scale or upgrade attached clusters, but you will be able to do everything else. So providing identity and access to teams via cluster groups or workspaces, which we'll talk about in the lab, running conformance testing and performing configuration and audit testing on attached clusters, data protection, so backup and recovery of Kubernetes clusters utilizing Valero with attached clusters, same observability and diagnostics data is surfaced, connectivity and traffic management integration with Tanzu Service Mesh. We also have observability and diagnostics integration with Tanzu Observability by Wavefront. So all of these features, except for lifecycle management, are available for attached clusters. And now TMC can attach to any Cloud Native Compute Foundation or CNCF conformant Kubernetes cluster. So whether you see the logos on the screen, whether it's Red Hat's OpenShift, Rancher, or even the hyperscalers managed Kubernetes service, AKS, EKS, GKE, things of that nature, Tanzu Mission Control can attach all of those clusters. Now, on the left side, we have provisioned clusters. And so these are clusters that were actually provisioned via the Tanzu Mission Control UI. And so this is where we utilize Tanzu Kubernetes Grid again to handle via cluster API to handle lifecycle management of the clusters. So when you provision a cluster via Tanzu Mission Control, you have the ability to obviously provision and create. You can scale the cluster up, you can scale it down, you can upgrade the cluster. So all of the basic lifecycle management operations can be performed via the web UI and Tanzu Mission Control. So that's very valuable for operations teams to enable developers to create clusters with a couple of button clicks, and we'll look at that in the next slide shortly. So as you see, there are a couple of asterisks on the left. So today we support provisioning to AWS, and now that is not provisioning an EKS cluster. This is actually instantiating EC2 instances and deploying a TKG cluster on top of AWS. So this is not exactly deploying EKS. You as the end user have complete control over the control plane of the Kubernetes cluster because it's a TKG cluster deployed on EC2. We have vSphere support coming shortly on the roadmap, and so that will basically involve Tanzu Mission Control talking to vSphere 7 with Tanzu and or TKG multi-cloud in the future to enable users to provision clusters to on-prem infrastructure via Tanzu Mission Control. And then we're also going to support further down the roadmap Azure as a platform as well. So the same kind of scenario as AWS, where we're provisioning Azure instances and then layering TKG on top of those instances, so users have kind of full control over the control plane. And so the vision here is that the experience is exactly the same for multiple infrastructures and platforms to support the management and provisioning of clusters. So before we dig into the kind of feature and use case overview, I want to go ahead and perform, for those of you that are going to follow along on the lab, part of the lab includes provisioning a TKG cluster live, and that operation takes about 10 to 15 minutes. So I want to go ahead and take a break from the slides, and we're going to hop over to the hands-on lab to start that provisioning process. And while that cluster is provisioning, we can come back and talk a little bit about the use cases of Tanzu Mission Control while we wait for the cluster to provision. So give me one sec here, and I'm going to switch screens over to my browser window. And I will also paste the direct link to the HOL lab that we're going to use in the chat. So I just sent that over. You can click on that and it should take you directly to the hands-on lab entry for the session. So give me 1 second, I'm preparing my browser and I'll be right back. All right, so now we're looking at the HOL platform, and for those of you that are joining these sessions for the first time, VMware Hands-On Lab is a really awesome tool that allows our users for free to create accounts and get access to live environments that include various VMware technologies. So all the way from kind of your basic SDDC environments to kind of learn the ropes of vSphere infrastructure, all the way up to labs like this, our TMC lab, as well as vSphere with Tanzu and other, NSXT, Avi networks, all kinds of stuff in here. So I recommend for those of you that are not familiar with the platform to, take some time, to kind of browse through what's available, because there's a lot of great content in here. So just as an aside, I myself am actually the lab captain for the Tanzu Mission Control hands-on lab. So I've written the manual and built out the pod that we're going to use today. And so I kind of have more insight into the creation of this lab and can provide kind of additional context about why we've made certain decisions and what we're showcasing in the lab. But if you click on that link in the chat, or you can just go to https://labs.hol.vmware.com. If you come up here at the top and search for Tanzu Mission Control, you can enroll in the lab. And so if you haven't logged in and you click enroll, now actually one thing I want to mention, there are 2 Tanzu Mission Control labs available. One of them is a simulation. That's not the one we want to utilize. We're going to utilize the full lab. This simulation is available, and it's just kind of a canned demo of some of the use cases we cover in the HOL. But this is for situations where we have high capacity in the real lab. But I've got this, we've got the lab reserved today for this session. There was a question in the chat from Luis: can you recommend a learning path for Kubernetes in VMware Labs? So there's a couple of things that I would recommend. So if you come over to the All Labs and click on Cloud Native Applications, there are a couple of great labs here. One of them is Containers 101. So this is kind of the very basic kind of getting started with containers. And then we have managing and extending Kubernetes. So this is when you start to get into building Kubernetes clusters and running applications on Kubernetes clusters. And then we're also shortly going to release a Tanzu Kubernetes Grid HOL that'll be here in the Cloud Native Applications section. But we also have something that our team builds and owns called Kube Academy. And so this is Kubernetes architects at VMware that are kind of the best and the brightest in the Kubernetes space. They kind of support high-profile engagements and large-scale Kubernetes opportunities here at VMware. Also have a portion of their team that is focused on kind of education and enablement. So I'll paste this link in the chat here as well. But there is a ton of great content, again, for free on the Kube Academy channel. So getting started, Containers 101, Kubernetes 101, all kinds of stuff on this website as well. But this is more kind of videos and demonstrations, whereas the HOL is actually hands-on labs where you can actually kind of get get access to stuff. We also have, I think we're actually moving it over to the Modern Application Platform catalog here. That's where you'll find additional content on the Kubernetes space as well. So if you click on the Modern Application Platform catalog, you'll see Tanzu Mission Control, Tanzu Service Mesh, TKGi, which is formerly known as VMware PKS. So a lot of great content here. And then the TKG multi-cloud lab is going to be here as well. So between Kube Academy, Cloud Native Applications Catalog, and Modern Application Platform Catalog and HOL, that's probably where I would recommend to start. So we're going to enroll in VMware Tanzu Mission Control HOL 2132-01. So if we click the enroll button, we'll log in here. If you do not have an account already, you can click this register button to register for free. And I already have an account, so I'm going to log in. And then I'm going to go ahead and start the lab. And click start the lab again. And so this will pull up a Windows console that will allow us access into the HOL environment. So while that's loading up, let me pull up a diagram in the manual to kind of talk a little bit about the, the architecture of the lab. Let's see here. Okay. So as a quick introduction, for those of you that are new to this session, the HOL lab console, on the left we have a Windows console that is basically our window into the isolated environment that hosts all the infrastructure that we're going to use for the lab. So this will be where we actually interact with the environment over here in the Windows console. Then on the right we have the manual. So the lab manual is what us lab captains create to ensure that we kind of provide kind of step-by-step guidance to kind of cover various use cases for our lab. So as I mentioned in the last session, these environments are completely live and are real products and real kind of deployments of products. So you can do kind of whatever you want if you're familiar with the products, but we also provide kind of step-by-step guidance in the manual to walk through specific use cases. So the idea is someone that's never seen Tanzu Mission Control can come in and use the manual from page 1 all the way through page 294 to kind of experience the product and learn without having kind of questions about what they're supposed to be doing. So the first thing I want to do is I'm going to click on the table of contents up here. Let me see where it is. Yeah, so, okay. So I'm going to click on the table of contents. In module 2, under introduction, there is a lab environment tab. So let me click on that. And so we'll take a look at the lab environment. So the HOL, what we call vPods, and that's essentially what everyone that's checked out a lab gets access to, is an isolated virtualization infrastructure that usually includes, for kind of the vSphere centric labs, usually includes some sort of nested VMware SDDC deployment. So in our lab, in the vPod environment, we have our Windows Control Center over here, which is the console that provides us access to the environment. And then we have a single Linux VM where we host our Kubernetes and Docker cluster for the attached workflow. And so that's really it as far as what lives inside the isolated vPods. Because for our lab, we do a lot of our work on, via the quote unquote public internet. So we reach out to VMware Cloud Services to access Tanzu Mission Control, and we use Tanzu Mission Control to actually provision a cluster into AWS. So we have 2 clusters. We have the Kind cluster and the TKG cluster that we utilize in this environment, one running in the vPod and one running in an AWS account. So each user in this lab gets access to their own instance of VMware Tanzu Mission Control that is paired with a dedicated AWS account for as long as the lab is provisioned. So that's pretty neat and a great way to kind of experience the TMC product in real time, because it is a real live environment that is capable of provisioning and managing existing clusters. So hypothetically, what I'm saying is if you have kind of an existing Kubernetes cluster out there in the world, you could attach it to Tanzu Mission Control and that you access via this HOL, and play around with it for the duration of the lab as well. We provide clusters in the workflow of the lab manual, so you don't have to do that. But if you're curious and you want to play around with your existing infrastructure, you're more than welcome to do that. So that covers it for a little bit overview of the lab environment. So first thing I want to do now is provision a cluster before we go back to the slides. So I'm again on module 2. I'm going to click on the student check-in and go ahead and perform the student check-in. This is an automation that we have written to populate your account with populate your user or your TMC account with a set of users. So the first thing I'm going to do is click on the Chrome icon to open a Chrome window. We should automatically be brought to the student check-in page. So here you type the email address that is associated with your hands-on lab account that you just created or you already created. So my VMware email address. So when I click search, these are the logins that I'm going to use to access TMC. We have 2 logins that we've created for use in this lab. We have the platform admin, which is kind of the, what you would guess, the kind of highest level of user, highest level of access. And then we've created a developer login because in some scenarios in the lab, we look at kind of restricted access and what that looks like. So you can come back to this page and quote unquote check in at any time, but if you want, feel free to take note of the logins right now. And so you'll have to actually click on this hyperlink under the platform admin to actually create the user in the cloud services portal. So once that's done, you click on the next page, the username should be auto-populated. You click next, and then you sign in with your VMware password, which should be VMware1 bang. So capital VMware1 exclamation point. And if you mouse through in the manual, this is all detailed as well. So VMware1 exclamation point, and then click sign in. So essentially what we've done thus far is we've gained access to a VMware Cloud Services account and user account, which is what we'll use to access the Tanzu Mission Control service. Now, as an aside and for future reference, we also added 2 VMware Tanzu Service Mesh modules into the lab. We won't be covering those in this session, but it's because it was a nice little bonus that we were able to add. So if you're interested in learning about Tanzu Service Mesh, the VMware Tanzu Mission Control HOL is where that stuff is included. So this user now has access to TMC and Tanzu Service Mesh on their account. So we're actually going to click on the Tanzu Mission Control tile and open up our TMC portal. So this is what a kind of blank Tanzu Mission Control console looks like. So we have various kind of tabs over here. We have the ability to attach an existing cluster, create a cluster from scratch. So the first thing we're going to do is create a new cluster group. So cluster groups are essentially a way for operations teams to group sets of clusters together to give teams access to a set of clusters or resources. So there's, this is just another way to promote multi-tenancy with TMC. So kind of the developer A has access to the developer A cluster group that includes the 6 clusters that they use, developer B and C and D, so on and so forth. So we're going to click the cluster group tab and click the create cluster group button, and then we're going to use hands on labs as the cluster group name, and go ahead and click the create button. So now we've got our new cluster group, and we're ready to create a cluster in that group. So we're going to create, click on the clusters tab over here, click on the create a cluster button. And then here's where we define kind of the configuration of our TKG cluster that we're going to provision in AWS. So the first thing we choose here is AWS account credentials. And so in preparing an AWS account to support cluster provisioning, TMC essentially allows you to generate a CloudFormations template to add to your AWS account to link TMC to that AWS account to support cluster provisioning. And so when you create that account credential, it will appear here. So you could create multiple credentials for multiple accounts and use RBAC to limit users to certain account credentials. And so we only have one in, so it chooses that one by default. We're going to do TKG cluster as the cluster name, and then select hands-on lab as our cluster group. So we can also add a text description as well as key value labels for the cluster if we want to as well, but those are not required. So we hit the next button, and then here's where we configure kind of the location and configuration of the cluster, so to speak. So we're going to select an AWS region. So these are the regions supported currently for TKG deployment via TMC. So we've got US West 2 configured to support cluster creation. So when we pick US West 2, we're automatically populated with the SSH key that's available. This is so we can access the nodes of the cluster which are deployed on a private network via a bastion host, just in case, for troubleshooting purposes or customization or things like that. We can also choose the Kubernetes version that we want to deploy. So we support N-2 for minor releases of Kubernetes. So you can do 1.18, 117 or 116. So we're going to choose the most recent here for versions. You can deploy into an existing VPC if you like to, or you can a TMC will utilize the CloudFormations template to create a new VPC. We can specify the VPC CIDR if we want to. I'm going to leave that by default. We can also specify the pod and service CIDR of the cluster if we want to as well, but I'm going to leave that by default as well. So now we click next, and so now we're selecting the configuration of the control plane. So we can choose the instance type, the size of our control plane node, and we can also choose whether we want kind of a development cluster or a single node control plane, or an HA or prod cluster with a 3 VM control plane. So we can also choose the availability zone if we have, say we choose the HA control plane, we can place each VM in a different availability zone for maximum availability. For our lab, we're going to just use the single node control plane and ensure that M5 large is the instance type. You can choose whatever availability zone you want. I'm just leaving it at the 2A default. And now we're ready to hit next. And then here is where we configure the node pool or the worker nodes in the environment. So we can create a name for the node pool. I'm just going to leave it as default. We can create a text description. We choose the worker instance type, so I'm going to leave this at M5 large. And we can also choose the number of workers. So I'm going to change this to 2. So our cluster that we provision is a single control plane cluster with 2 worker nodes. So now we are ready to create the clusters. So we've defined kind of the configuration of the cluster, and now we're ready to create. So after we hit create, we'll see that the cluster is being created, and this will take about 10 or 15 minutes, and we'll be able to then kind of interact and manage our cluster via TMC. So let me pause my screen share to get back over to the slides. Actually, before I do that, it might be a good idea for those of you that are following along to come up to the top of the browser here and click extend to extend the time of the lab, because when the lab ends, all of the infrastructure is deleted and we kind of have to start all over. So you can extend this to occupy your lab up to, I think, 8 hours at a time. So if you plan on kind of playing around with this all day today, then feel free to extend this as much as you want. If you're just going to kind of keep interacting with it for the course of this lab today, then just extend it for another hour, so that when we come back, you won't you'll have plenty of time to interact with it. You'll get a warning in the console when you're running out of time, and you can go up and extend as well. So not a big deal. Okay, so while we wait for that to provision, let's hop back over to some slides here to talk about the various use cases for TMC. So give me one sec. Okay, so we talked a little bit about the product itself, and I kind of want to take some time to go over in more details about the use cases and some of the problems we look to solve with Tanzu Mission Control. So this is the high-level architecture of TMC, and TMC is really at its basis a multi-tenant SaaS platform that today lives exclusively on cloud.vmware.com. Give me one second. Sorry about that. Today, as I said, today this is SaaS only. The entry point is via the cloud services portal. We're looking at, and we have on the roadmap, an on-prem version of this that will provide similar functionality, but it lives, on-prem and managed in your own customer or partner managed infrastructure. So essentially, each customer has access to their own policy engine that can be applied to a certain resource hierarchy. So the resource hierarchy applies to clusters that are provisioned by TMC as well as existing clusters. So that's kind of the point I made earlier. Except for lifecycle management, you have exactly the same control over attached clusters as you do for provisioned clusters. So that's important to, an important thing to consider. So if you start at the bottom layer, TMC can provision Tanzu Kubernetes clusters. Today on AWS EC2 and soon on vSphere and Azure. TMC provides full lifecycle management for those clusters, so provision, upgrade, scale, delete, et cetera, et cetera. But that's not the only way to manage clusters in TMC, and you can attach AKS, EKS, GKE, VMware Tanzu Kubernetes clusters, PKS and TKGi clusters. Any conformant CNCF conformant cluster can be attached to Tanzu Mission Control. So once you have kind of a set of clusters available, if you move up a layer, we have resource hierarchy. So cluster groups, as I mentioned earlier in the HOL, allows you to organize Kubernetes clusters into logical groupings. So for example, to align with a business unit, to align with an infrastructure platform, whatever our users see fit. If you cluster groups allow us to separate clusters into groups. Workspaces allow you to organize namespaces into logical groupings across clusters, perhaps to align with development projects. So for instance, if you have six Kubernetes clusters and you are running a version of an app for testing on each of those clusters, you can create that, say it's a WordPress app, you can create the WordPress app namespace on each of those clusters create a workspace in TMC that involves and is made up of all of those namespaces across all of those clusters, and give your WordPress developers access to that workspace. And so what that means is they have access to that namespace on every cluster, but they only have access to that namespace. So you don't have to give them access to each cluster admin access to each cluster. You can only give them access to a certain namespace across 5, 10, 15, 100 clusters. So that's kind of a pretty powerful vision as we start to kind of talk about the product and things like that. So by combining these resources into groups, our operations teams can simplify management by applying policies at the group level. So for example, you can apply an access policy to an entire cluster group rather than creating separate policies for each cluster. So that means each time you add a user to a certain cluster group, they get access to all of the clusters in that group. And each time you add a new cluster to that cluster group, all of the existing users now have the same level of access. So this allows for very kind of simplified federated management of Kubernetes clusters across kind of different sets of infrastructure, or different even Kubernetes distributions. So if we move up the policy engine layer, policies allow you to provide a set of rules that govern your organization and the objects that it contains. So we have different types of policies in TMC. So access policy is one. So access policy allows you to use predefined roles that specify which users and groups have what level of access to a cluster group, a workspace, even a namespace. So that's what I'm talking about, where we can kind of govern who and what has access to what kind of layer of the stack. We also have security policies that allow operations teams to impose constraints on clusters that define things like what a pod can and can't do, which resources they have access to change, things of that nature. We also have network policy. So network policy allows you to use pre-configured templates to define how pod communication is limited between namespaces or even between clusters and other networking endpoints. We also have image registry policies. So this allows for operation teams and even developers to control what image registries are supported for pulling container images to run. So you can, if you only want to utilize your managed container registry to support applications, you can provide a image registry policy that only allows containers to run and applications to run on your cluster if they come from that registry. So that's another pretty powerful feature. And then finally, namespace quota policy. So this is the ability to create CPU and memory quotas on a group of namespaces or a single namespace from TMC. So we really want to provide kind of management of the Kubernetes stack and infrastructure in TMC in the quickest way possible. So now that we've actually provisioned a cluster, let's look at what happens when we do that. So we've already walked through kind of the UI experience in the HOL, so I won't spend much time there. But this is actually what's happening. So when we click that Create Cluster button in TMC, the TMC control plane provisions the necessary resources in the AWS account, creates a cluster according to those cluster specifications utilizing the Cluster API project, and then attaches that cluster to the specified cluster group that we define. And so in our case, we're talking about TMC utilizing the CloudFormations template to instantiate and create all of the resources required to support this Kubernetes cluster. So creating ELBs, VPCs, EC2 instances, instantiating those EC2 instances as Kubernetes nodes, and then continuing to provide management capability for those. And so this will look, from the end user, this will look exactly the same no matter what the underlying platform is when we add more supported platforms for provisioning. So as well as provisioning clusters, you can also do what we refer to as attaching clusters. So this is really bringing existing clusters into the hierarchy. So essentially, from a high level, on request of an attach, we deploy a cluster agent in the Kubernetes cluster to attach that service, that Kubernetes cluster to TMC. And we'll do that in the lab, so I won't spend much time here talking about the workflow because we'll talk about it there. But essentially, it deploys a set of agents on the cluster that phone home to TMC, so to speak. So there is no incoming firewall requirements for TMC to attach clusters, but there are some port requirements for the cluster agents running on the cluster to be able to talk to TMC on the outgoing channel. So something to keep in mind. TMC doesn't need to talk to ingress into a cluster in an environment, but the cluster needs to be able to talk to the public internet to communicate with the TMC SaaS portal. So we've talked about kind of the infrastructure layer and the actual Kubernetes cluster. So let's look at the resource hierarchy, the next layer up. So I've talked a little bit about cluster groups and workspaces, but we essentially have kind of the highest level of the hierarchy is known as an organization. And so this is really tied to the VMware Cloud Services Portal organization, or CSP organization. So that's the root level of the hierarchy tree. So you can assign access on the organization level, and that means that trickles down to everything in the TMC instance. You can also create cluster groups like we did previously in the lab, and then apply policy to those cluster groups. And then you can create workspaces which could span, which include namespaces that could span multiple clusters. So you could do things like create a cluster group for your production WordPress application, and give all of your SREs kind of cluster admin access to any cluster in that environment. Or like I mentioned earlier, you could create a workspace that just involves the WordPress namespace on those clusters and give your SREs admin access to the workspace. So they can't or don't touch any other namespaces in those clusters, but they have root level access to the namespace they need access to. So you have a lot of ability to control that. So now that we've talked a little bit about the hierarchy tree, let's talk about policy-driven cluster management. So you can easily manage security and compliance by leveraging TMC's policy engine to apply consistent policies like access, security, network, image registry, namespace quota. All of those policies can be applied to any cluster under the control of TMC. So TMC has various policies that can be applied to orgs, cluster groups, and workspaces. So some of these policies can be applied to cluster groups by platform operation teams since they're cluster-wide configs. And then a few of these policies will be applicable at the workspace and namespace level because the application teams will be using them. So platform teams can use cluster-wide policies to define some ground rules, but application teams have additional control to apply certain policies at the namespace or even workspace level. So things like network policy and image registry policy, developers can define those at the namespace level to have complete control over how and where their application is deployed from. So for a more manageable security posture, TMC allows users to combine the members of your organization into logical user groups and then secure those groups with access policy. So VMware Cloud Services Platform, cloud.vmware.com, which is what we use to access TMC, is used to invite users into organizations and organize them into groups. So you can federate your existing IDP, so AD or LDAP, into the VMware Cloud Services portal to utilize that as well. So if you already have kind of an IDP with a directory structure and a group structure, you can seamlessly integrate that into TMC to kind of give that existing group access to a set of resources in TMC. So that's a pretty neat opportunity. So we've already talked about this a little bit. I'm going to try to speed through these next couple of slides because we're going to touch on these in the live demo. But this is a look at image registry policy. So essentially, the application teams can add approved registries in Tanzu Mission Control to ensure that only containers and images from certain registries are allowed to run in the cluster. So in the example you see on the screen here, our customer has an on-prem Harbor deployment, which is an open source, enterprise open source container registry, cloud native registry solution, as well as they want to allow GCR, Google Container Registry, images from GCR to run on the cluster, but they do not want to allow any images from Docker Hub to run. So if a user tries to deploy an application that pulls something from Docker Hub, the application will not run on the cluster. So pretty neat that we're giving the developers the ability to control that in TMC without having to kind of write maybe cumbersome or complicated YAML configuration files to set up the admission controllers to allow that. If we look at network policy, we also give app owners the ability to write ingress network policies for organization or workspace level. So deny all, allow all, deny all for a pod where we can put a label to deny all traffic for a certain pod, or allow all for a pod where we can kind of create a deny all rule and then use a key value label for a certain pod to allow ingress traffic. So in the example to the right, we have our coffee shop app where we have written a rule to allow traffic to the coffee shop app, while we have a deny all policy on the workspace that denies all ingress traffic to any other pods, including the bookstore pod. So that's just an example of a network policy implementation. We also have namespace quota, which is pretty new feature that is just added that allows for CPU and memory requests and limits to be applied at the namespace level. And so we have t-shirt sizes out of the box, custom quotas can be created, and then we can also define outliers that we can exclude specific namespaces or only include a specific namespaces with key value labels. So we have the ability to do that as well. We also can talk about cluster inspections. So Sonabuoy is the open source tool that we utilize to perform inspection. So Sonabuoy is a diagnostic tool that makes it easier to understand the state of a Kubernetes cluster. It allows for running a set of configuration tests in a non-destructive manner. So conformance is really important because of portability as a tenet of the value of Kubernetes. So one of the things we preach and all kind of Kubernetes users and vendors preach is the ability to run your application on any conformant cluster. And so Sonabuoy helps test that conformance. So this will test to make sure that the cluster you're running is conformant and is able to support your application. We also have introduced the CIS benchmark inspection that evaluates your cluster against the Center for Internet Security Kubernetes benchmark. So CIS is a nonprofit entity whose mission is to identify, develop, validate, and sustain best practices for cyber defense. So this is just another security benchmark that we've included in conformance testing in TMC, and we'll walk through that in the lab as well. It's a fairly quick lab that we can just simply kick off a quick conformance test just to look at the workflow for the inspection. We're also going to be offering the ability to run custom conformance tests. So there are a lot of power users and teams out there that are writing their own Sonabuoy tests to utilize to ensure that all their clusters in their environment across all platforms are conform to their personal security specifications. So that's coming on the roadmap as well, custom inspection tests. Data protection is another feature that was recently added, which I'm personally a huge fan of. It's a very, very neat feature. So under the hood, TMC is utilizing Velero. And so Velero is an open source Kubernetes backup, recovery, and migration project that is sponsored by VMware. Came from the Heptio team and the Heptio acquisition. They started the project. And so we essentially utilize Velero to do backup and recovery to S3 buckets. So today we only use AWS S3, but in future releases we'll be able to support any storage destination with an S3 compatible API. So things like Minio, Cloudian, things like that can support backup are going to be available to bring the backups on-prem as well as in the public cloud. And so you can back up an entire cluster, you can back up a specific namespace, or even specific resources in the cluster using key value labels. So very kind of granular ability. This is pretty cool because the vision here is that this feature will support in the future migrations of applications, namespaces, or even entire clusters from one cluster or infrastructure to another. So if you're looking at doing hypothetically a deprecation of a certain infrastructure or a certain cloud or a certain on-prem solution and you have Kubernetes workloads running there, you can utilize the data protection feature in TMC to do a backup and recovery of your existing cluster, move that application or those namespaces over to a new cluster, and then decommission the old cluster. So it's a pretty, the roadmap for this feature is very, very promising and very, very cool to play with, and excited to add the hands-on lab module probably later next week, so everybody can start to play around with it and test it out. So we also provide another new feature, logs. We provide audit logs. So to help our operations team monitor the activities that occur in the organization, TMC provides logging of audit events. So this includes audit logging of service level actions that are performed through TMC, as well as cluster level actions that take place on clusters that have been provisioned in TMC. So basically giving users insight into operations that have happened on the cluster if something goes wrong. So that's kind of a quick overview of the feature set. So now give me 1 second, we'll hop back over to the lab and make sure that our cluster is provisioned. Okay. All right, so if you're like, your screen's like mine, you may have to hit return to lab, which will just reload your Windows console. But since everything else we've done is, the lab hasn't ended, it's saved all of our work, so to speak. So let's give it a couple of seconds for this to load back up. Okay, so looks like my cluster has mostly finished. If I hit this refresh button here in the top right-hand corner, I'm guessing everything is done. Yeah, okay, so what we're going to look to see here is we want to make sure that we have all of our agents and extensions in this green healthy state. So all these agents and extensions are what TMC utilizes to manage and interact with the cluster. So things like policy sync extension is how we gain access to the cluster. The gatekeeper operator, that's how we do security policy with OPA. Extension manager, that's the agent that runs on the cluster that manages all of the extensions to ensure they're all healthy. We have an inspection agent that handles inspections. So these are all kind of the management components of TMC that's running locally on your Kubernetes cluster. Up here, we can ignore these controller, manager, and scheduler under component health. This is something that we're working on. It was a change in the upstream Kubernetes that wasn't caught in time, but we'll have an update for this in the product shortly. So that's another kind of advantage of TMC as a SaaS product, is we can push changes and fixes to TMC in real time. So we don't have to wait for kind of a new product release or a new minor version release, like for the on-prem solutions maybe that VMware offers. We can kind of make additions and changes on the fly. So if you scroll up to the top, you can see kind of base level information about the clusters, cluster group, the provider, the version, the number of control plane and worker nodes, the number of pods running, total CPUs, memory, the account, all that good stuff. So let's hop back over to the manual to see what we're going to do next. So we've already deployed our cluster. So now we're going to actually deploy a local Kubernetes cluster. So we're going to use Kind or Kubernetes and Docker to deploy a local cluster to attach. So this is kind of the use case for attaching an existing cluster that maybe TMC didn't provision or didn't know about previously. So we're going to use our Linux VM in the pod to do that. So if we click on the PuTTY icon and open up the PuTTY window, we can click on the Kind host profile or session and then open. And so you should be auto logged into a Linux terminal. And now we're going to use Kind to create a cluster. So I've talked about this in previous sessions, but in the HOL manuals, you can highlight text over here on the right, and then you'll get this little glove icon, and you can click on the text and drag it over into the console to copy and paste, so we don't have to type out this long cluster. But this is the command that we'll use to create a 3-node Kind cluster, and as you can see, we're utilizing this 3-node YAML configuration that just defines the configuration of our cluster. And so while we're doing that, I'll talk a little bit about Kind. I'm going to zap back here to Kubernetes and Docker. So we're utilizing Kubernetes in Docker. We talked about that a little bit in the last session with TKG multi-cloud. Kind is a really awesome tool that allows users to quickly test things on Kubernetes clusters on a single workstation or virtual machine. So for instance, I have Kind installed here on my Mac workstation, and it utilizes Docker Desktop to essentially build a local Kubernetes cluster on my Mac, utilizing Docker containers as the Kubernetes node. So it was initially used by the Kubernetes open source team to kind of rapidly test code changes. So being able to rapidly spin up and test clusters quickly. But if you're just getting into Kubernetes and you want to kind of be able to play with a cluster and you don't have any lab infrastructure, Kind is a great tool to install and deploy on your local workstation. While that's loading up, let's see. Paste this in the chat so you have it, and that's the web page for Kind that you can utilize to play with Kind. So now our cluster is finished deploying. So if I do kubectl get nodes, this is looking at the nodes of my Kind cluster running locally on this virtual machine. So now we have the TKG cluster that I provisioned in the AWS account, or we provisioned in the AWS account via Tanzu Mission Control. But we also have what I'll refer to as an existing local Kubernetes cluster that was provisioned outside of TMC. And so we can now walk through the workflow of attaching that cluster into Mission Control. So I'm going to go back to the table of contents and click on Attach Local Kubernetes Cluster, and we're going to access the TMC console and walk through the workflow for attaching that. So here in the TMC console, I'm going to minimize the PuTTY window here. Click on the clusters tab. So if I click here, I'll be able to see that I have an existing TKG cluster down here once this loads. Yeah, so we see the TKG cluster that we already provisioned. We see it's in healthy status. We see the provider and the version, the resource allocation. Instead of create a new cluster, I'm going to actually attach a cluster. So this is the existing cluster workflow for attaching. So I'm going to name the cluster kind cluster. I need to fix this in the manual, but we're going to choose the hands-on lab cluster group. We could put a description or labels here if we wanted to, but I'm just going to click next. So essentially what we get now, TMC creates a YAML configuration file that deploys the agents on the local kind cluster or whatever cluster you're attaching. So it's kind of hard to see in on my screen, but there's a little copy to clipboard button right here that you can click that will copy this entire command to the clipboard. So once we have that kubectl create command, we can click the copy to clipboard icon to copy the command. We can return to the PuTTY session. I'm going to maximize this. Right click to paste, and so that'll paste our kubectl command. Hit enter, and so then we can see all of the resources that are being deployed. So namespace, config map, some CRDs, custom resource definitions, some cluster roles and role bindings, some services and deployments. If we go down to the manual on step 3 over here, we can click this or highlight this watch command, click and drag that over to the cluster, and we can actually watch the services and pods being deployed in the TMC system namespace. And so once we have the extension updater and agent updater and manager running, it will pull down the rest of the container images and instantiate the rest of those services on the cluster. So I'm just going to take a quick 30-second break here while we watch these deploy, and I'll be right back. Okay, so now we see a bunch of additional pods. So the rest of the agents are starting to be deployed on our kind cluster. And so we don't necessarily need to wait for everything to go into the running state. If we go to the next page of the manual, we can come back to the Chrome browser and click this verify connection button at the bottom. And so we can verify that the kind cluster was able to connect to TMC. Then we can click view cluster to have a look at the cluster. So this page looks similar to what we saw of the TKG cluster. We can see some of our agents are still deploying, which is fine and expected. Eventually this will all go green, and we'll get things like allocated memory, allocated CPU, additional information shown. You'll notice that we have provider unknown here. This is because we don't have any sort of CNI network interface or CSI storage provider configured for any sort of infrastructure. So if we're deploying this on vSphere and we have a storage provider configured for the vSphere CSI, then this will show vSphere. We obviously have the storage provider configured for AWS for the TKG cluster, so that's why it shows provider available for our TKG cluster. So feel free to browse this tab. We can continue to refresh this. Yeah, so it shouldn't take that long. So now we have information about the allocated CPU and memory, the number of worker nodes, the component health, things of that nature. So we're in good shape there. So now we have provisioned a TKG cluster via Tanzu Mission Control, and we have attached an existing cluster as well. So obviously in our PuTTY session, we have access to our cluster already. I can hit Control-C to kill that watch command. So because I provisioned this myself, I obviously have access to the cluster. I can run kubectl get pods-a, but now that I provisioned my TKG cluster in TMC, I need to figure out a way to access that cluster as well. And so this involves using the TMC command line interface to authenticate against the Cloud Services portal. So we'll walk through that shortly. So the first thing we need to do is download the Tanzu Mission Control CLI. So we'll click here on the Automation Center and then click on the Download CLI dropdown, and then click on Windows 64-bit to download the CLI. Once that CLI finishes downloading, ensure you click the Keep button down here to maintain the executable. You'll note that for simplicity of this lab, we've added the downloads directory into the Windows path. That's not best practices. We just wanted to keep this as simple as possible for the end user. So now that we've got the CLI downloaded locally on our Windows desktop, we need to create an API token that we can use to authenticate against the Cloud Services portfolio. So the first thing we'll do is click on our username up here in the right-hand corner, and then click on My Account, and this will take us to our Cloud Services portfolio portal account. Then we click on the API token button, and then click Generate a New Token. So this is a token that we'll use to authenticate against the portal. So we can name it TMC HOL token. We're going to leave this at, or change it to 8 hours for the token life. We're going to choose all roles, and then we're going to generate that API token. So that will give us this this randomly generated API token that we'll use to authenticate. So you can click the copy command here to copy the token, and then hit continue. So after copying the token, we're going to open PowerShell locally on the Windows desktop and type TMC login to authenticate against the TMC portal. So the first thing we need is our CSP API token, and the TMC command line gives you the instructions to generate one if you don't have one already. But we just copied it, so we can right click and paste the API token, hit enter. So login context, we're going to do HOL and then your number. So mine is 07 admin. That number is, you can find it up here in the top right hand corner, TMC HOL, and then a 2-digit number. So mine's 07. That's what I'm going to use. It doesn't really matter. This is only for your use, so you can name it whatever you want, but this is just a suggestion that we had in the manual. Choose info for the debug level. Here is where we select the default credential. So if you're going to provision clusters from the CLI, this is the credential that it uses to provision clusters. So we're going to choose TMC HOL 07. And then we're going to choose the default region, which US West 2 is the only one we've configured in this lab. So we're going to choose that. And then we're going to choose the SSH key. So we only have one, and we're going to use that default SSH key. And so now we have authenticated and we're configured to access the cluster. So the next thing we need to do is return to the TMC console. So if we click on the Cloud Services link in the top left-hand corner of the UI, and then click on the TMC tile again, we're back into the TMC console. So now we're going to actually click on our TKG cluster and go to the overview page for our TKG cluster. If you look in the top right-hand corner, you have an Actions tab. If you click on that Actions tab, you have a couple of options. So we can move this to a new cluster group, we can view policies, we can even delete it. But if we want to access this cluster, this is how we do that. So we can download the kube-config file, which is what kubectl utilizes to know where to kind of communicate to the cluster. So we can download it to the downloads directory. We can also, if we wanted to, we can view the YAML file that includes the certificate authority, the token, and things like that kubectl will use to access the cluster. But I'm going to just click download kube-config file. Did it download? There we go. So I see it down here in the downloads bar. Now I can click OK. And now we're going to hop back over to PowerShell. And we're going to change into the downloads directory. So I'm going to copy this over into my console to change into the downloads directory. I'm going to move that kube-config file that I downloaded. So it's currently in the downloads directory, and it's kube-config-tkgcluster.yaml. I'm going to move that into the .kube directory under the config name. This is the default location that kubectl looks for. So if you have a single cluster or a single configuration file, usually it's kept here. So kubectl looks here automatically. You can also set environment variables if you want to maintain the file in other locations. But move the file there. We can look at we can run an ls to examine the location or the contents of that hidden kube directory to make sure that our config file is present. So now when we run kubectl get nodes, kubectl looks at that configuration file we just pulled down and spits us back information about the cluster. Now what happens behind the scenes is there is configuration in that file that instructs kubectl to look for some sort of authentication token that was created when we did the TMC login up here. So if we did not do TMC login, we would get a not authorized when we tried to interact with the cluster. So by performing this TMC login, kubectl is able to utilize the config file to verify that we as a user that's associated with this API token have access to the cluster. So that's the workflow for accessing a provisioned cluster. And so this can all be automated by the CLI. You won't and don't have to do this every time you want to access your cluster. And once this is done once for a given cluster, and once you have created an API token for a given user, especially if you have the expiration defined as on an order of months or years, you only have to do that process once as well. So that's the authentication process that we use to gain access to provisioned clusters. So now we'll just deploy a quick sample application on the cluster. And actually, I think we're going to skip this because we're running a little bit low on time. So let me look at the table of contents and see kind of where we should go next. Give me 1 second here. Okay, so we're going to take a look at the policy module, which is fairly big. I think that's probably the only one we'll have time to complete or to look at today. But I just want to stress that except for the week of VMworld, where all of these labs are offline and dedicated specifically to the VMworld event, you can come in and take this lab at any time. And if you have the cycles today after we end this session, you can continue on. If you want to pick up in another 3 or 4 days, you can continue on. Most of these modules, you can start fresh from any module and complete the lab. You don't have to do modules 1, 2, 3, 4 to do module 5, for example. So feel free to take a look at that. But we're going to do module 3, working with policies, and we're going to start at the workspaces and namespace section. So I'm going to click observe the existing namespaces in the environment, and we'll start from there. So if I click on the namespaces tag, this will show us all of the existing namespaces in all of our clusters that we're managing in the environment. So we can see that some of the namespaces have labels already. We could add labels to namespaces if we want to. Some of the labels are, some of the namespaces are labeled. For example, we have the VMware system TMC namespace on both the TKG and the Kind cluster, and they're labeled with labels from TMC that TMC automatically applies when that namespace is created. So now we're going to create we're going to observe the existing workspace, and we're going to create a new workspace. So if we click on workspaces, we already have a default workspace that's created by default that we can use if we want to, but most of our users are going to manage and create their own namespaces. So I'm going to click the Create Workspace button. The name of my workspace is going to be HOL Analytics. I could create a description and a label, a key value label if I wanted, but I'm just going to go ahead and create that. So now I've got my new namespace, my new workspace created. Now I'm ready to create a namespace within that workspace. So I'm going to click on my HOL Analytics workspace, and then click on the Actions dropdown, and then create new namespace. So I'm going to create, one second. Okay, something's wrong with the manual. But basically, I'm going to create a namespace here, the development namespace in that workspace. So going to create the name as development, and then I'm going to create that namespace on my TKG cluster. So before I do that, I just want to show you, let's go back to, so the PowerShell session in this lab is what we use to access the TKG provision cluster. The PuTTY session is what we use to access the Kind cluster, just to keep those things separate. So now I'm on the PowerShell cluster, so my kubectl commands are talking to the TKG cluster. So if I do kubectl get ns or get namespaces, this will show all of the namespaces that currently exist on my cluster. So I have the default namespace, which is created automatically for any Kubernetes cluster. And then I have a couple of system namespaces, kube system, kube public, kube node lease, and then VMware system TMC, which was created to support the TMC agents and extensions that are deployed on the cluster. So when I come back to the UI and click TKG cluster and then click create, if I come back to my PowerShell session and run that get namespace command again, we now see that that development namespace is present. That was not present previously. So we're performing actions in the UI that are instantaneous on the actual cluster itself. So that's pretty neat. So now what I'm going to do, and I'm kind of going off book here a little bit, just to kind of save some time, just because I can do this from memory. But the manual details this workflow as well. I'm going to come to the policy section. So this is where we define who and how has access to certain clusters or certain workspaces, or setting up image registry, network, and quota policy. So the first thing I want to do is I'm going to give my developer access to the workspace. I'm also going to give my developer access to the hands-on labs cluster group. So I click on clusters, I click on hands-on lab. If I open the disclosure triangle, I see that I have 2 clusters here for TKG clusters. So I'm going to create a role binding here. And for role, I'm going to give them cluster group view. So this gives my developer user access to just view the resources in this cluster group. So I'm going to give my user access. So I could choose a whole group, but for this example, I'm going to do user. And then for user identity, we're using the email address from that is plugged into the cloud services portfolio. So if I come to the student check-in, again, I can highlight, hold on a second. I can highlight this email address, which is my my username for my developer. And then paste that here. So I click the add button and create. And so essentially what this does now, if I open this direct access policy, this gives my developer user that previously didn't have any access to the service the ability to view any cluster that's in the hands-on lab group. Now, I want them to have more access on any namespace in the HOL Analytics workspace. So I'm going to click on the Workspaces tab, come over to HOL Analytics, drop down the direct policy, and create another role binding. So for this role binding, I'm going to give my user Workspace Admin. So that gives the developer user the ability to create image registry, network, and quota policy on any namespace in this workspace, and gives them the ability to deploy applications to any namespace in this workspace. So I'm going to paste the user again and add that user, and then click create. So now if I drop this down, the direct access policy, my VMware, my 407, my developer user now has workspace admin access to the environment. So now what I'm going to do, I'm going to open an incognito browser. So right click on the Chrome tab and open an incognito window. Click on student check-in, and I'm going to check in as the developer user again. So, or excuse me, as the developer user. So my email address, and you actually have to click through this link for the developer login now, because that will activate the user in the VMware Cloud Services account. So clicking on the hyperlink will take me through. I can hit next. The password is capital VMware1 exclamation point. Here, I'll go. If you look at the table of contents, we're basically picking up from here. So we have hold on a second. We have essentially rechecked in. We've clicked on the developer login. We have signed in with the new user. Again, the password down here, capital VMware1 exclamation point, clicked sign in, and now we are at the cloud services account for our developer user. So if I click on Tanzu Mission Control, I've been logged in and I now can see both of the clusters. And so let's walk through some of the additional access policies. So if I'm just going to change to light mode because it's a little bit easier to see, and it helps me keep the developer login and light mode separate from the admin login and dark mode. So if I click on policies, you can see and observe that if I'm looking at the organization level, which is the TMC HOL level, I don't have permission that allows me to view or edit access control. If I click on the hands-on lab, I also don't have ability to view what the access control is for my cluster group, because I only have read access on the cluster group. If I click on the kind clusters, the same thing is true. I don't have the ability to view who else has access or things like that. However, if I click on the development namespace, I can see via inherited policy that I've been given workspace admin, so that's my user account. I've been given workspace admin on the workspace, which allows me admin privileges on the namespace. So if I wanted to, because I am in charge completely of this workspace, I could add additional users to this namespace, or if I come over here into workspace, I could add additional users to this workspace because I have the ability and have been given complete control there. So that is something that we can enable developers to have complete control over what they need to have complete control over, while the operation teams can continue to kind of lock down the cluster. But one thing I'm going to do now is I'm going to remove some level of access to the environment. So I'm actually going to come back over to my platform admin login, number beginning in 3 instead of 4. And I'm going to click back over to the cluster group, click on hands-on lab, and I'm going to remove that user's access to cluster group view. So that means they won't be able to view the clusters. They'll only have access to the namespace. So if I click here, yeah, so now I can't see any cluster groups. I can't see any clusters. I think I can see my workspace, and I should be able to see my namespace, but that's the only thing I can get access to. So it's a pretty limited set of access as far as the console is concerned, but we'll look at why that matters and why that could be useful. So we've essentially set up an access policy posture that allows for our developer to essentially access any namespace that's in our HOL Analytics workspace, which right now is only the single development namespace. So what we're going to do now is create a new what's called TMC CLI context with the API token from the developer user. So we're on the developer user's account. We're going to click the developer user and then my account. So this is the same process for the API token for the platform admin, but now this is for the developer user. So TMC HOL token. Do 8 hours, all roles, and then generate. So we're going to do the same thing. We're going to copy, hit continue, and now we're going to come back to our PowerShell session and run TMC login again. TMC login. So we're going to copy our new API token. In this context, we're going to call TMC 07 dev. So the last one was TMC 07 admin. This is our dev context. So all the same selections. That's fine. Okay. So 1 second, let me look at this. So now we've got 2 contexts, and let's see here. Whoops. So now we want to verify that the context we're using is current, is valid. So I'm going to click this TMC system context current command, copy that over here. So this will ensure that we're using the TMC developers TMC CLI context. So this is, we can ensure that we got our 407 user here. So this is what now kubectl will use to verify that we have access to the cluster. So if I do kubectl get namespace, I am forbidden because I don't have access to all of the namespaces in the cluster. However, if I do kubectl get namespace, get namespace development, I can see and get information and status about the development namespace because my platform admin has given me access to just that namespace. Now, let's say I want to deploy a sample application in that namespace. So this is deploy an application in the development namespace in the table of contents. So step 3 here, we can deploy, use this kubectl -- namespace development, apply, and then cafe services, which is an application, sample application we've included here. And then that will allow me to deploy the application into the cluster. Now, hypothetically, if I did something like this and tried to deploy it into, say, the default namespace, which I don't need to include that, but I can see that my my user, my VMware 407 is not allowed to deploy resources in the API group apps in the namespace default. So this gives us the ability, or excuse me, gives the platform admin the ability to kind of completely lock down the cluster, but my developer still has access to the namespace they need to deploy their applications. So now if I do kubectl -- namespace get pods in the development namespace, I can see that my coffee and tea pods are deployed successfully. Oh, wait. Oh, I forgot. Okay. So let's see. This is interesting. So I forgot a step after we provision the cluster. We'll go back and do that just now in a second. So if I do kubectl namespace deployment get deployments, I can see that the deployments have been deployed coffee and tea, but they're not in the ready state. And that's because TKG clusters deployed via Tanzu Mission Control are automatically deployed with a really strict pod security policy. So once we confirm access to the cluster, there is one step that I forgot to perform. Let's see here. We need to create a pod security policy right here. So we need to create a pod security policy that allows for elevated privileges for our user to provision clusters, but I'm actually not going to be able to provision or to run this because I'm using a different, let's see here. Yeah, because I'm using the developer context, I can't do this because I don't have cluster admin. Let's see. TMC system context use TMC 07 admin. So I'm going to switch to the admin context, run that command again. Whoops, HOL 07 admin. Okay, wow. So now I'm using the admin context, so I should be able to run the command to create the privileged role binding. Now I can switch back to the TMC07 dev user. Apply the command again. We do kubectl get pods -n development. Okay, so we'll delete this. Okay, so the pods weren't starting because the security policy was in place. Now, if I apply the YAML file again, now that I've created a privileged cluster role binding, look at the pods in the development namespace. This is the dangers of a live demo. Give me 1 second. I have to come back and revisit that. But the idea here is that the developer user, once the cluster is configured to support workloads, is able to create resources and applications in their namespace. So and then view resources in the namespace. So even though nothing is deployed, I can see that there's nothing deployed in the development namespace. But if I do kubectl get pods -a, which is show me every pod on the cluster, I'll get a forbidden message because I don't have access to access every namespace and every pod in the cluster. And so we only have a couple of minutes left, so I want to quickly jump to conformance testing because that's something we can show pretty quickly. So I'm utilizing the platform admin user, my VMware, the 30X or 307 instead of 407. If I click on inspections, I can run an inspection. And so I can choose the cluster. I'm going to choose the TKG cluster. And we have a couple of different options. So conformance testing is a full suite test that runs, I think, about 350 tests to ensure that the cluster is completely conformant. That takes up to 4 hours. We obviously don't have the cycles for that. The CIS benchmark is a more prescriptive test that's only about 90 operations and criteria. So we're going to run that. We can also run the light test, which only takes about 3 or 4 seconds, and that ensures that basically everything is running and can support a workload in general. But we're going to click CIS benchmark, click run, and so this will actually communicate with the TKG cluster to run the conformance testing and the benchmark testing. So I think if we look, let's see here. So we're going to switch back to the admin context. Just trying to catch some of the conformance test pods running in the VMware system namespace, but we might have missed it. So hop back over to the CLI. Whoops. And we can see that the test is already completed. A little bit of worrisome because we see a failure, but if we click on that test, we can see that we have a little note here. Some Kubernetes implementations, including clusters provisioned through Tanzu mission control, mitigate vulnerabilities in ways not tested by this inspection. So all that is to say that if you click on this view documentation link, we basically call out the specific tests that we expect to fail in a CIS conformance testing, and then we give an explanation of how we mitigate that failure in another way other than what's specified and checked for by the test. So even though we do display a failure there, we have an explanation for any failed tests for any TKG cluster. Now, obviously, this won't be the case for clusters created and managed via other vendor solutions, but this is just a nice way to provide enhanced visibility for your security of your clusters. And so we just introduced the ability to schedule, but you can also download the results as a file as well from the portal. So that about wraps it up for the time we have today. Again, thank you so much for joining. For those of you that sat through all 3 sessions, I hope there was some value there in the sessions. Thanks to the phoenixNAP team for helping us put this on. And again, like I said, these labs are available for you at any time to utilize. We're going to send out and we share the recordings for all these sessions after the fact, so you can go back and review the sessions. But the manuals themselves are complete enough to where we create them so that you should be able to perform these from start to finish without much kind of issues. So you should be able to use the manuals to step through all these use cases as explained. But again, thank you for your time. Feel free to reach out to me on LinkedIn or via email, jomann@vmware.com for any follow-up questions, and we hope to hear from you soon. Thanks.